Good morning everybody, my name is Shankarji. Now we will be studying chapter 12, Electricity and Circuits. So first of all, what do you mean by electricity? Electricity is the flow of charge in the form of electrons. So what are electrons? Electrons are subatomic particles. Electrons are very small, invisible particles which revolve at high speeds around the nucleus of an atom. They are very small, we cannot see them. However, they have lot of energy due to their high velocities. They have lot of energies. So that's why when electrons start flowing, electric current starts getting generated, and that's why we call it as the flow of electricity. So what is electricity? Electricity is nothing but flow of charge in the form of electrons. And electrons are taken as negatively charged particles. We have given them the negative convention to it. Protons, they are given as a positive sign, and neutrons are given 0. That means they don't have any charge. The three main subatomic particles are electrons, protons and neutrons. Electrons are negatively charged particles, protons are positively charged particles, and neutrons have no charge. That means the charge on neutrons is taken as 0, is equal to 0. We need to use electricity properly. We have to channelize the energies. So one of the best ways of doing that is to create a cell, which is known as an electric cell. So now we will study about something known as the electric cell. So what do you mean by the electric cell? The name itself indicates that you are going to create an object which will use the electricity, and we can channelize the electricity for various applications, for our various energy requirements. So an electric cell is an object or a device or an instrument which converts chemical energy into electrical energy. Because you put some chemicals inside it in the form of anode or cathode, you put some solvent or solution, and from the chemical energy you are converting it into electrical energy, which can be used for various applications. For example, I have this wristwatch. So the electric cell which this wristwatch has is known as a dry cell. It's known as a dry cell, also known as a Lagrange cell. It's a simple cell. It's like very small. I mean, you just take a small, the cell battery is like this. Very small. You might have seen the watch wrist cell battery. So it has a small cell. Inside it has two compartments. One is positive, one is negative, and you have some kind of powder form, or it might be a gel or something like this. So this generates a small electricity, like maybe 1.10 volt, or a small power electricity, which can be used for. That electric energy can be converted into mechanical rotation of this watch. That's how this watch is working. Because if the cell was not there, the dry cell was not there, the electric cell was not there, then how will this mechanical watch work? That's why electric cells are very useful. I mean, without electric cells, most of the instruments will become useless. And this particular branch of electricity can also be called as electrochemistry. So electrochemistry is a wide field of physics and chemistry which is very useful in the field of science and technology, and also in our everyday lives. For example, the wristwatch, dry cell, even the wall clock. So what will we do without cells and batteries? It's almost, we cannot imagine a world without them. We'll take a small example. If you connect a bulb to an electric cell, what will happen? It will light up. Why it will light up? Because the electric cell gives the flow of electrons, gives the electricity to the bulb, and the light bulb close. So that's the power of electricity. That's why it's called, that's why whenever electricity is on, we say power. Because electricity is power. So it's an immense power. So electricity is the flow of electrons, and it gives us a lot of power which can be used for various useful applications. Now, electric circuit. What do you mean by electric circuit? An electric circuit is a pathway where the electric current is supposed to travel. The path where the electric current travels is known as electric circuit. To control the opening and closing of the electric circuit, we need a particular device known as the electric switch, also known as the switch or the key. So normally we have the switch, like maybe it's in the off version when you on it. Off, like off version, on version. So what happens when the switch is in on position? The circuit is closed. When the switch is in off position, the circuit is broken down. So the electrical symbol for the switch is just put a small dot and with the two brackets. The proper symbol for cell is one long stick and one small stick, positive, negative. So a group of cells is known as battery. A single cell is indicated by just a big line and a small line, positive and negative end. But a group of cells is known as battery. A battery is nothing but a group of cells joined together in series, just right next to each other, just like a train. And this is a simple example of an electric circuit. I've taken a few cells, I've converted that into a battery, so that each cell has, say, 1.1 volt. So into 3, I get total voltage 3.3 volt. So this 3.3 volt, I want to use it for lighting a bulb. So I connect it to a switch and then I connect it to a light bulb. What happens the moment I turn on the switch, the circuit gets closed and the electric current starts flowing and the light bulb is shining. The moment I turn on the switch, the circuit is broken down and the flow of electrons stops, and therefore the light bulb turns off. So this is how electric circuits work. This is just an example of a simple electric circuit. Everywhere electricity is used. Without electricity, without magnetism, without flow of electrons, we can't even imagine science and technology. So it's absolutely crucial. This is just a simple example of an electric circuit. There are many electric circuits possible, maybe on a small size, big size, depends on the requirement. But electricity is the key to all electric circuits. Now, we talk about electric conductors and insulators. So, what do you mean by electric conductors and insulators? The name itself says conductors, insulators. Conductors are those substances which allow electricity to pass through them freely. Even our bodies are absolutely very good conductors of electricity. That's why when we touch an electric switch without insulation, we get shocked, we get electric shocks. And it's very dangerous because our bodies are very good conductors of electricity. So that's why it's always advisable to wear some rubber shoes or boots before and also some hand gloves before you work with some electricity, because electric safety is very important. Not only our bodies, even water, even metals. These are examples of very good conductors of electricity. They immediately allow electricity to pass through them because there are a lot of electrons available. They are ready, they are just free electrons. The moment some energy passes through them, they get excited and electricity is readily available. That's why conductors are substances which allow electricity to pass through them very easily. However, insulators are those substances which resist electricity, which do not allow electricity to pass through them, or very little electricity to pass through them. Practically, they don't allow electricity to pass through them at all. For example, the wood, to some extent, to a large extent, plastic, even plastics they don't allow electricity to pass through them, etc. There are other groups. There is one particular group as well. It is known as semi-conductors. Semi-conductors or semi-conductors. Semi or semi-conductors. For example, there are a few elements like silicon, germanium, etc. These elements, they are also known as metalloids. They sometimes behave like metals, they sometimes behave like non-metals. However, at room temperature, they are insulators. But the moment you give them energy, in the form of heat or light, they start conducting electricity. They become conductors. So without these semiconductors, even our mobile phones, no laptop, cell phone, even our cell phones, digital camera, everything is based on this semiconductor technology. So we should be thankful to semiconductor that modern 21st century technology we are able to use it. Otherwise, it will have been very difficult. They have infinite scope. Yes, that's why semiconductor technologies is ruling the market, because all electronics, communications, IT department, satellite, everywhere semiconductors are used. So it's a big field. It's a vast field. So it's a very fascinating field. So even if you want to do a PhD in semiconductors, you can do it, and you're highly valuable. You can become a very great scientist as well. Those cells which can be reused again and again, they are rechargeable cells or batteries, and those cells or batteries which can be used only once, they are known as non-rechargeable cell or batteries. So let me recap this chapter. We discussed what is electricity. Electricity is a flow of charge in the form of electrons. Then we discussed electric cell. An electric cell can be a simple cell like a dry cell. It can also be a group of cells like a battery. You can also have a nickel cadmium battery like the Amaron battery which we use in our cars. That's a combination of a few cells and you are putting in the car, and when you are igniting the car, you are just turning on the car battery, and the car battery, the chemical energy inside the car battery is getting converted into electrical energy, and that ignites your car. So we talked about electric cells, and then we discussed about electric circuit. Electric circuit is a pathway of the electric current. The path which the electric current takes place where the circuit is closed, that is known as electric circuit. And we discussed about electric switch, which can turn on and off, which can break the circuit or which can join the circuit. That's why we have the switch, also known as the switch key or electric switch or a switch key. Simply it's known as key or switch or electric switch, which can be in the on-off mode. So we have three main categories of substances: electric conductors, insulators and semi-conductors. So conductors are those substances which allow electricity to pass through them easily, anytime, be it low temperature, high temperature, anytime. Insulators are those substances which completely block, which don't allow electricity to pass through them. And semi-conductors are substances which are normally insulators at room temperature, conductors at higher temperatures, or sometimes if adequate light is available, they become very good conductors. So if you have any doubts or suggestions, please mention us in the comment section below. Thank you so much. Have a great day.